So I'm Alex Weinert. I'm the Director of Identity Security for Microsoft. I'm joined by Scott, and Pam, played today by David Turner. Pam may be joining us later, or she'll see if she can get over, and I'm going to see if I can figure out the clicker. I have a brief part in this first part of the talk, and then I'll be back. Mostly I wanted to say welcome. Super excited that you're here. I hope you enjoy the session and you learn something that you didn't already know. The idea here is to make sure that everybody's level set and has a good baseline of knowledge going into the rest of the week. So core terms and concepts, core value props and things like that. Who here is able to log in with a Fido token now? Okay, so like pretty good knowledge base. And then who's doing some kind of deployment in your organization for Fido? Still like 20%, so pretty good. All right, awesome. All right, so our goals here, again, are just understanding the overall authentication landscape and how Fido plugs into that, understanding the basics of how Fido works, the security promise, that'll be my part, and then we're going to talk a little bit about what the experiences you're having are. So if you have interesting stories or questions, then you can save them up. We're going to take some time at the end and have a little bit of discussion time. And with that, I guess one other thing is just, there's lots of resources here. So there's a link tree for Fido 2. And so there's resources that are available to you through the link tree. And I have not played with the link tree, but I hear they're really cool, so you should check it out. And then with that, I'm going to introduce Scott, and Scott's going to take you through the authentication landscape.
Good morning. Thank you for being here. This is fun. This is going to be a great couple of days. And I've really been looking forward to this Fido one-on-one session. Let me introduce myself really quickly. My name is Scott. I have been working in technical product management for the better part of the last decade, mainly in the consumer-focused apps and services space. Most recently, I was working for a company here in Seattle. I started out selling books. I got pretty good at that. And now they sell funny little robots, and my old boss is a space cowboy. So, weird world. But within the last year, I moved over to Microsoft. I'm in the identity team now. And so this is new to me too. And when I first started learning about authentication and Fido, it was a little bit overwhelming. There's a lot of terms to understand. There's a whole glossary of acronyms, new technologies to be familiar with. But what I found was that the authentication community is very welcoming. And I think part of the reason for that is that the problems that we're trying to solve transcend conventional boundaries. Authentication is not just an industry problem. It's not just a company problem. It's not just a problem for some guy in IT. It's a world problem. It's a human problem. And as our lives become increasingly digital, it becomes increasingly important to secure that data. And there's a lot that goes into data security, but authentication is really the front door. And so all that to say, we're glad you're here. Welcome. And this is really going to be a truly one-on-one course. We're going to cover some foundational concepts, a couple terms, and then I'm going to turn it over to David, and he's going to explain what Fido is. So to start off, let's talk about what authentication is. And to do that, I'm going to use a real-world example of a situation with hopefully you're very familiar with, is presenting your passport at a TSA checkpoint in an airport. So you're walking up, you've got your passport, you have your boarding pass, you have your little rolly bag, and you wait 3.5 hours for the privilege of going through TSA. And when you get up to the checkpoint, we're going to do something called this little authentication dance. Sometimes it's called an authentication ceremony. And there are 3 parts to this: ask, act, and validate. And we want to make sure, or the TSA agent, we'll call her TISA, wants to make sure that you requesting access should have access to that secure space. And so we have these 3 parts. And the first part is she's going to ask. In her most friendly neighborhood TSA agent voice, she's going to do something like boarding pass and credentials, please, or identification. And that's the ask. And then the next part is my part, and I'm going to act. And I'm going to present my documents. I'm going to give her my boarding pass and my passport. And then her very important job is to make sure that the name on the passport and the name on the boarding pass match, and the photo on the passport and my face match, and that those documents are valid and unexpired and good. And so she's going to take a look at them, look at me a couple times, and if she's happy, she'll let me through. And that's it. That's authentication. And so next time that you go through an airport, I want you to think about that. You give over your documents, they check the documents, you're validated, you walk through, and you go, yes, I successfully authenticated. So let's talk about this in a digital context. These 3 same steps still apply: to ask, act, and validate. And we authenticate digitally far more frequently than we go through TSA. We do it 50, 100, 200 times a day. You authenticate when you put your passcode into your phone and on the lock screen. You authenticate when you type a password in to access a site or a service. You authenticate when you use Windows Hello to sign into your desktop. And there are a lot of different ways that this plays out. You have user to service. You also have service to service. Computers need to talk to each other too. So let's quickly just define what authentication is. And simply, the authentication is the process of proving that the user with a digital identity who's requesting access is the rightful owner of that identity. And so when we do that, we can control access to systems, applications, files, networks, and more. So now that we've got a fundamental concept of what authentication is, let's look through the landscape, and we'll explore some of the common types of authentication that exist today, the inherent risks, and some things we've done to mitigate those risks. And we'll start with the most basic, the username and password. This has been around since the dawn of computing. Way back when, we needed a way to restrict data to certain users or groups of users, and we came up with this: a username, a piece of public information, and a password, a piece of secret information. And we've known for a long time this is pretty rudimentary, and it doesn't solve a lot of problems, but it just won't die. This has been around forever, and I think there's a couple reasons for that. The first is that it's very CX friendly. Customers or users will know how to use this. You put a username field and a password anywhere, and they're going to know what to do. The other thing that makes this really strong is that you can put this on any type of surface. You can put it on a desktop. You can put it on a tablet. You can put it on a smartphone. You can put it on a calculator, and somebody would know how to use this. But for all the CX virtues it has some serious security problems. And the first of these is that people love bad passwords. 1, 2, 3, 4, 5, 6, and password top the charts every single year on our list of most commonly used passwords. And there's a few reasons for this. One, they're easy to remember. If you have to manage 90 different online identities, you don't want to do that over and over and over again. You're just like, I just need something simple. You can do this. The other thing that makes this very non-secure is that they're easy to type too. So you can just QWERTY a password, and then you've got your password. The problem is that when you have a password that's easy to remember and easy to type, it's probably easy to guess. And so we're going to discuss a couple threats that come with these weak passwords. And the first is something we call password spray. And password spray is when a very naughty person gets a list of usernames for a particular service or app, and then they just use these top passwords against that list. They go right down the list: Cameron, Anita, Raj, all the way down to Scott. That's me. And if I'm using QWERTY, then they're in. So some serious risks there. And this brings me to one of my favorite authentication quotes, is that hackers don't break in, they log in. And we see all these memes of hackers with those cool hoodies, with lines of code running down their computers, and that's not what they're doing. They're typing QWERTY. They might not actually be typing it. They've got scripts that can run through hundreds and thousands and millions and billions of these passwords at once. And so it's not super difficult to brute force your way into an account that's using a simple password. So we as an industry realized that simple passwords simply don't work. So what did we do? We responded with education. We started off saying, you can't just protect your entire digital life with these simple passwords that everybody's using. So we gave some guidance. Use 12 characters or more. I put an uppercase letter in there, a lowercase number, a special character. Don't use simple patterns. Don't use a password you haven't previously used. Don't put any part of your username. We have all these different things to try and guide users to these passwords. And we ended up with something that looks like this. And so users like, well, maybe I'll do this. And we've actually found that depending on where they're setting up their credentials influences the strength of their password sometimes. So if they have access to a desktop and you're asking them to do this, they might do that because they've got their whole full layout keyboard there. But if you're asking them to do this on mobile and they have to go through 3 layers of keyboards to find that special character, probably less likely to do it. But if you're asking them to do this on like a smart TV, there's no way they're going to do that. They're going to do 1, 1, 1, 1, 1 all day long because there's no way they're entering this to watch Netflix with a remote. And so we also found that even if you do this, there are just some things that are intrinsic about passwords that make them don't work. And we found that passwords just don't matter. So even if you have 12 characters, or even if you have 13 characters, you want to be extra secure, your password doesn't matter. And so let's go through a couple threats about why that's true. And so the first one that we have is phishing. And phishing is simply when an unauthorized person gets access to your credentials, either through coercion or deception. And this can take a lot of different forms. And so we have email, for example. I'm sure you've received an email from a foreign dignitary who's asking for your banking credentials to save their country or themselves. They're phishing for a password. Or SMS phishing. We call that smishing, which is fun to say. You get an email or a text message from somebody from your power company. He's like, we're going to turn off your power if you don't give us your credentials to your power account. Whatever it is. They're social engineering. When a terrible granddaughter asks grandma for their password to get rid of all those viruses and pop-ups, and she's really just trying to get into her bank account. And we even have like voice phishing or fake websites when a bad actor creates a look-alike website. It might just have a tiny tweak in the domain name or somebody clicks to it through a malicious link that's just capturing usernames and passwords. So even if you've got the most secure, most crazy obscure password, it's 60 characters long, it doesn't matter if it gets phished. So the other threat here is we have password reuse. And so I've got my 13-character password that IT came and said, you've got to create a new password. It's been 90 days. So I go through the step there. And you've probably seen this enforced in UI, right? You're typing in your credential, and there's a list of like 10 grayed out specifications that your password has to have. And as you're typing them in, they turn this nice, pleasant shade of green. You feel really secure. You've got a good password. So that took me 25 minutes, and I've got my good password. I'm very happy with it. And if it's good enough for my corporate credentials, it's probably good enough for my bank. And so I use the same password at my bank. And if it's good enough for my bank, it's probably good enough for my social media. And so I use this password for my Facebook account. And then, if it's good enough for that, I said, well, I found this really cool site called myfreecrypto.com. Don't actually go there. I don't know if it's a real site. But I'm going to put it in there. I'm going to create this credential. It's going to be secure. But when myfreecrypto.com gets compromised, the first thing they're going to do is those bad actors with the hoodie are going to start using this password everywhere they think that you are. And so they get into your Facebook account. And they know, hey, I know this person lives here. I know they bank here. They're going to try and get in your bank. And it just goes back and back. And then they have this whole problem with password reuse. So again, it doesn't matter what your password is if it gets compromised through password reuse. And what's shocking is how easy this is to do. In June of 2021, the largest compilation of passwords was leaked with 8.4 billion entries. So even if you have these great passwords, and even if you're not reusing passwords, and even if you are pretty keen on smishing and phishing, and you are, feel pretty protected there, there's a high probability your password is floating around somewhere. And you don't even have to go to dark web to find these. These are posted on Twitter all the time. You can find these repositories of these passwords. And so we as an industry said, let's take a look at the data here. And we found that greater than 99.9% of breaches happen when the credential is protected by a password only. So we said, this isn't good enough. We've got to find something new. And so the industry came up with something called multi-factor authentication. You've probably heard of this before, MFA. It's called a lot of different things, a lot of different variations. MFA, two-factor authentication, or 2FA, two-step verification. The underlying principle is the same. We need to find something else to prove that this person with this identity requesting access is who they say they are. And a password is one factor. But what if there's something else that only that person had that we could use to help confirm their identity? And you might have heard multi-factor authentication described as something you know, something you have, and something you are. So any two of these things would constitute MFA. So let's take a quick look at these one at a time. Something you know could be a password. Most commonly is a password, but could be anything. It could be an answer to a security question that you've made up. You know, who is my second grade teacher's tallest son's rabbit's name? It could, and then the next factor we have, something you have. This could be a device like a phone or a laptop. It could be an access badge, a security key, a software token, a one-time password, something that you have on your person. The next factor we have is something that you are, and something intrinsic to you, a fingerprint, a facial scan, a voice print. It could even be a heartbeat rhythm, something that you are. And when we have these three things, we have a stronger concept of authentication. So instead of the password and username field like you might have seen before, we've got something like this now. We have the username, the password, and the second factor. In this instance, we have a one-time passcode. And these one-time passcodes can come through email, or they could come through SMS, or you might have a dedicated Authenticator app. So problem solved, right? We have multi-factor authentication. We know it's something that you have, something you are, and something that we know. And we took a look, and the data doesn't lie. MFA reduces compromise by 99.99%. It's very difficult to compromise an account that has MFA implemented. But that's not the whole story here. And what we found is that when we implement MFA, there are some trade-offs, some significant trade-offs. The first one is it's slow. You've introduced another step. And so there's two hoops to jump through. And so you've got to type in your password, which is now 13 characters long, plus you need to request a code, let's say by SMS. And if your phone is, maybe you have bad service, it takes a while to come, you've got that, now it's like a 9-digit code, you've got to enter in that, and if you're trying to do that on your mobile device, it can get a little clunky. So it's a little bit slower, it's a little bit clunky. And traditional MFA, or legacy MFA, is still not unphishable. If we looked at these things we had earlier, SMS and email, if those are both, email can be compromised if it's just protected by a password. And SMS can be compromised by SIM swapping or somebody calling the mobile carrier and say, please help me send the confirmation code to my other phone. So it's still not 100% unphishable. So while multi-factor authentication is successful, and it's something we have, are, and know, it's also clunky, phishable, and can be slow. And so we're realizing that any type of authentication method that we want to be successful has to meet a couple criteria. It's got to be usable and it's got to be secure. And so we've come up with this little graph here that has these charted. Okay, we have usability, very easy to use, very difficult to use, and we have security, very secure and not secure. So up in the upper left quadrant, we have simple passwords. You can QWERTY that. You've got a password, but we know that's easy to do, but it's not secure. And we talked a little bit how you can create these complex passwords and that are much more difficult to enter or type on a TV remote, but they're still not that secure. Said, okay, well, let's introduce MFA. But we did that, we degraded the user experience. Waiting for codes, waiting for things to pop up in your app, or waiting for an email address, or for your code to come through your email. So what we found is that we have this whole quadrant up here, that we have this opportunity. It's got to be easy to use, it's got to be secure. But even if we did have a solution that was easy to use and it was secure, that's not the whole story. It's also got to be interoperable. It's got to work on your desktop, it's got to work on your tablet, it's got to work on your phones, it's got to work everywhere, it's got to work on different operating systems. And if you don't have that, if it's not interoperable, it's not going to succeed. The other component here is that it has to be trustworthy. If you can't trust this thing, we're not going to implement it. And if you work in IT and you are used to deploying these kinds of things, you've probably been approached by a security vendor who says, we've got the perfect solution for you. It's easy to use. It is secure. It works on all your devices. But how do you know that it's been properly vetted, that it's been properly tested, that it's not actually some bad actor who's phishing? There's some problems there. So we have the interoperability and we have the trustworthiness. Both of those things can be solved with something called a standard. So unfortunately, there's not a standard definition for a standard, which I think is funny, but we're going to use this one because I like it a lot. A standard is a repeatable, harmonized, agreed and documented way of doing something. So to take this out of the abstract, we're going to use a real-world example. So this morning, I was making a protein shake, and I plugged my blender in, and it just worked. And that was awesome. I'm sure you do something similar every day. You plug something into an outlet, and it just works. But let's take that back to where that electricity came from and how it got to your house. So here in Washington, we use a lot of hydroelectric. So way back at a river somewhere, A river is coming through a dam and is turning turbines and it's generating electricity. And that electricity is taken all the way to a power station, a relay station. And that electricity is transferred over power lines or underground until it arrives at your house, where it comes to a fuse box, fuse panel. And then from the fuse panel, all that wire goes to your different outlets and switches, and then you plug something in and it works. But how does that happen? Well, this is made possible because of standards. The voltage is consistent. It's been standardized. It's 120 volts coming out of there, or 240 volts. And when you put an appliance into your socket, you don't have to worry about that it's going to blow up or that it won't work because the voltage isn't fluctuating. You also don't have to worry about on your plug how far apart those prongs are. It's going to work in every single outlet. And you can take that same blender and you can take it to your friend's house and it's going to work. So it's interoperable. So there's safety and there's interoperability that come with standards. And even everything is as simple as like the size of the circuits in your fuse panel and the colors on the wires are all standardized. And there's a lot of benefits to this. From both a consumer perspective and a deployment perspective, infrastructure perspective. So let's talk about this from a digital perspective, though. So we have a few familiar digital standards. We have Wi-Fi, we have Bluetooth, we have USB. These are all standards that make our lives easier. And so think of just the chaos that would happen if these weren't standardized. If your laptop had one way of communicating, sending and receiving radio waves, and your phone had a different method of doing that. We had Wi-Fi and Fi-Wi, or we had Bluetooth and Greentooth. It would be absolute chaos. And you couldn't produce routers because you couldn't possibly hope to match up with all these different standards. But we have these standards. And so it makes our lives a whole lot easier. From a user perspective, I don't have to worry about it. It's safe, it's secure, it's trustworthy. And from a deployment perspective, you get a lot of economy of scale. You don't have to worry about these things. It's cheaper to produce. It's cheaper to know that no matter what device is using this, it's going to work. So let's take a quick step back here and go to our original ask. If we're going to reinvent the world, if we're going to change the way that authentication works today, there's a couple things that this new type of technology has to accomplish. It's got to be secure. It's got to be better than what's on the market today. It's got to be better than your QWERTY passwords, and it's got to be better than these traditional forms of MFA. It's got to be easy to use, okay? We can't introduce something that's going to be harder to use than something that people are used to doing 100 times a day. It's got to be interoperable. It has to be work on all of your devices everywhere, and it's got to be trustworthy. So with that, I'm going to turn the time over to David to introduce a solution to this problem.
Thank you, Scott. And contrary to appearances, I am not Pam Dingle from Microsoft. I'm David Turner from the Fido Alliance, sitting in for Pam this morning. So I'm the Director of Standards Development at the Fido Alliance. So I'll be talking about Fido 2. So earlier Scott showed this slide and he talked about the ask, the act, and the validate. And so we've got this familiar login form. Everyone's used to it. You type in the password. It's horrible, as he said, but we're used to it. And then the validate takes place, and we know how untrustworthy that can be. So with Fido, we're making a big shift to the basic pattern and how it works. One of the first things, especially in the context of the browser, is that in the ask, one of the biggest risks with things like phishing attacks and so on is that someone can put up a screen that looks just like the password login screen from the site you're going to, but behind it, with JavaScript and whatnot, they can be doing all sorts of ugly things. One of the benefits of Fido and the WebAuthn specification I'll mention later is it comes up with both a standardized API, making it easier for developers, but also it provides protection against phishing attacks by making sure that that request is bound to the service that you're actually trying to log into. So we've got a standardized interface that's actually stronger than what you had before. And then you get the act. No more typing in passwords. Generally, you have a simple gesture of some sort. It's human-centric. It could be a touch. It could be a pin, face, whatever. There's a lot of different varieties that you can use. And then lastly, on the validate, this is no longer just a simple string compare. You don't have to worry because of how it works, and I'll talk a little bit more about public-private key and asymmetric key protection that is a core part of how Fido works. But what happens is you have these secure crypto keys that are being used to do the validation. It's not a simple string. So that if the the server, the relying party gets compromised and they steal all the information, they may get the usernames, but there's no passwords to steal. They can't reuse those and do all of the horrible stuffing type scenarios that, again, Scott was mentioning earlier. So the basic flow is a little different from what you're used to, as I described in the first screen. So we have our user, we have the service or the relying party, and the new part is we've introduced this thing called an authenticator. And it's now sitting in between the user and the relying party. And what happens is when the authenticator gets registered with the relying party, so there's this ceremony you go through to set up the key. In the same way as you set up an account, you set up the authenticator. And when that setup is done, a key pair is created, and there's the private key that stays with the authenticator. So that's the important part, and it never leaves the authenticator. It's always there, so it's always safe. And there's this other part called the public key, which you can give out to anybody. So when it comes time to even do the registration, a key part of the FIDO flow is, again, the user interaction. So you always want to have the user in control of the authenticator. So even at the time of registration, the creation of these keys, it requires some kind of user gesture to open up that private key so that it can be used in this registration ceremony and then ultimately in the authentication ceremony. Once it's been registered and the keys have been exchanged, then during authentication, what happens is that the relying party signs a challenge. So it's some unique code. They send that to the authenticator. And again, it requires a user interaction. The user must take some step in order to release or make use of, in this case, the private key. And so again, it can be a touch, it can be a biometric interaction of some sort. They enable the authenticator signs that challenge, and when it's sent back, the public key that relying party was given can be used to make sure that, yep, that's actually coming from the user. So there's a lot of steps going on behind the scenes, different from before, but you've actually ended up with, from a user standpoint, a simpler scenario where they're asked to interact, whether it's a touch, a pin, they take that step, and then the authentication happens. So even though there's all these other steps I just described, the user interaction is still fundamentally simpler than it was before. Excuse me. So this is a pre-session, and part of the intention of this session is to set up some knowledge and understanding of what's going to be happening through, or sorry, of what you're going to be hearing through a lot of the other sessions that are going on this week. There's a lot of terms that you're going to be hearing, and I just want to go through a few of those just to make sure everyone's clear on what we're talking about. When Alex asked about people who are using FIDO already familiar, there were a lot of hands up. Of course, we have a lot of people who are logging in virtually, so don't know what the percentage of those people are. So what I'm again going to go through is some of the more basic terms so that we have a clear understanding of what you're going to be hearing about in the subsequent sessions. So you've heard talk about standards. I'm going to address the relying party, what is the authenticator, a little more about gestures, the protocols or the standards that we're using, and then quick, brief discussion about the asymmetric cryptography. So what is a relying party? It's actually an easy one. A relying party, which can be a service or it can be the back end of an app, it's the party that relies upon the authentication. So it's the thing that's providing the service or the functionality that is depending upon the authentication that you are doing. So it's relying upon the successful authentication in order to then provide whatever services or capabilities the user is looking for. And then I talked about the authenticator. Well, what exactly is that? What does it actually look like? So I said it's this thing that sits in between. Well, what is that thing? Generally can take two different forms. There's what we call the platform authenticator, and those are the ones that are actually physically built into the device. So it can be a facial recognition system built into a laptop. It can be the fingerprint reader that's built into the phone. Many of you are, for the Apple users, you've got Face ID and Touch ID. Those are now FIDO-enabled capabilities. So when you use those to access websites using FIDO, which of course you won't often won't even be aware that that's taking place. Once you've registered, typically you'll just be prompted for your fingerprint and you'll automatically be logged in. That's a built-in authenticator. So it's built into the hardware of the device, and it's where the security is provided to protect that key that's in there. And the same would be true with the laptop. Those of you who are familiar with Windows Hello, it uses Fido in the background as well. So when you're logging into a website, you may get, you see a Windows Hello dialog pop up if it's Fido enabled. And again, it could be a fingerprint, it could be a facial recognition. It acknowledges you, and then it logs you in. The second type of authenticator is what we call a roaming authenticator. And the idea there is it's an independent piece of hardware of some sort. It can take a lot of different forms. It can be a physical key, like plugs into a USB dongle. It can be put into a smartwatch. There are even smart rings now that can be used as authenticators. And there's even scenarios where the phone itself can be used as an authenticator to a laptop. The benefit of the roaming authenticator is that you can take that key with you to other devices. So when you've got a platform authenticator, it's bound to that device, which has certain advantages. But there's other instances or scenarios where you may need to log into another device, let's say, that you don't generally have control over. And the benefit of using Fido there is that you can log into the service and never leave a password behind. So you can take your Fido key, and a great demo I like to show my friends is I use my key on my phone, which uses NFC in the phone to read the key. I do the Authenticate on my phone, and then I go to their phone, which has never seen me before, never seen my key before. I go to the same website, log in, and when it prompts me, I just use my key, and it logs me in. Get a lot of wows from the family when I show them that. And it works really well. So, and there are even more scenarios where platform serves you well and when roaming authenticators serve you well. But these are terms that you're likely to hear throughout as people talk about different things. People talk about security keys, they talk about dongles. Those are all, when you hear that, that would conceptually be what we call a roaming, pardon me, excuse me, a roaming authenticator. And then you're going to hear people talk about gestures. And this one's actually really simple. It's the touch. It's the PIN. It's the biometric modality that's being used. And it generally is just as simple as it sounds. In fact, not generally. It always is as simple as it sounds. I actually have a Surface machine, and I use the Windows Hello with the facial recognition. And sometimes it almost works too fast. If you know, I go to log in, and it's already prompting me to acknowledge it before I've even actually taken the step, which is good. It's very seamless, works very well, it's very smooth. So in many cases, the process of logging in is actually much faster than we're used to, you know, when it's when you're using good stuff. You'll get, I think, a lot of people are probably familiar, pardon me, with the same experience on Android with the fingerprint readers and with the Apple devices as well, because they tend to work very well in that sense, or in that way. So asymmetric cryptography. Again, you're going to hear that term quite a bit. I've already talked about it a little bit myself. It is at the heart of the technical part of the Fido protocol and interfaces. This is really where the security magic happens. And I'm not going to get into the specifics and the technical details. It's math heavy, let's say. But the basic idea is what I described earlier. When you have asymmetric cryptography, it's called asymmetric because you have a public key. One person will have a public key and a private key. And with Fido, you have a different public and private key pair for every site that you log into. And the private key is the thing, as I mentioned earlier, that gets saved by the user's authenticator or the machine, and it's the thing that's protected. The public key is the thing that you give out, and it's asymmetric because they have different purposes. They have different values, let's say. The private key is the really important thing. The public key, anybody can use it and have it. There's no security risk by people having the public key. So when somebody's doing the authentication, and I described the flow earlier, but I'll go through it again, the main way in which it's used in Fido is that you get a message that gets sent from a relying party to say, is this really you? And the private key signs that message, or is used to sign the message, pardon me. The message is then returned to a relying party. And this is where the public key comes into place. The public key can be used by the relying party to verify that that message was signed by the paired private key. So it then knows that I sent the message, only one person got the message, they signed it, I know what the message is, and I can now guarantee that and validate that, yes, it came from the right person. I have the right public key, I can confirm it came from the right private key. Now, you'll see all the little icons at the bottom. This is a very well-known, well-understood, not always easy to implement, but well-understood cryptographic mechanism. It's used in all of these different scenarios. It's how we do secure connections on the web. It's a key part of all of the cryptocurrencies that are out there today. There's other technologies, of course, that go along with these, but the notion of public and private keys is a very important crypto concept, and it's, again, from the security standpoint, it's really at the heart of what keeps Fido safe. I will add one last point, which is you will also hear a term frequently, which is public key infrastructure, or PKI. Fido's not using PKI because it's really important in this case, means infrastructure, as I said. And that actually brings in a whole more complex aspect of things, which isn't important for what we're doing with Fido. So you may hear people talk about PKI this week. It's a bit of a misnomer, but what they're really meaning is this public-private key scenario that I've just been talking about. So what are the specifications? There are two core specifications that comprise what we say, or what we mean when we say Fido 2. The first is called WebAuthn, or Web Authentication. This is a specification that was originally created in the Fido Alliance, but then contributed some years ago to the W3C. Primarily because this is an API set of interfaces that are defined within the browser. The problem with existing login scenarios, as I was describing earlier, is generally those password login screens are forms, or they're created with JavaScript, which is highly insecure, lots of risks for hacking, man-in-the-middle injection attacks, all sorts of threats. By pushing this functionality into the APIs of the browser, you get two benefits. One is standardization. We've heard about that already. In this case, it's standardized function calls, or API calls, which means that anybody who's trying to implement Fido, yes, uses the same interfaces regardless of which particular browser they're using. They don't have to be writing their own JavaScript for this part of the interface. It's all just the same whether you go from Chrome to Edge to Safari. So it makes the development experience, or the developer experience, much stronger. And by the way, that kind of simplicity also provides higher levels of security, because the fewer variations you have, the fewer attack vectors that are available. The second benefit is it's no longer in JavaScript. It's actually embedded into the browser, which provides a much higher level of security and trust than any JavaScript that you're going to create. So in the browser experience, we now have this consistent development interface that provides secure protection of the credentials. And the idea is when you're using something like WebAuthn, or through CTAP, as I'll describe in a moment, these are the only ways to get access to the credentials. So someone just writing JavaScript wouldn't be able to go and get these credentials. They must go through these protected APIs in order to make use of the credentials. So we have this extra layer of protection. Then we have CTAP, or the Client to Authenticator Protocol. I talked about these roaming authenticators, the dongles, the smart watches, and so on. How do they talk to the computer, right? How does it know to read my security key through the NFC interface? Well, what we've standardized is the interface between those roaming or external authenticators with the hardware. So currently we support USB, NFC, and Bluetooth. So any authenticator that supports one of those three, and there are some keys that support more than one of those, is able to be communicated with either through the operating system or through the browser through WebAuthn. And what this means is that any security key that is FIDO compliant, and by the way, we do have a certification program to assure compliance with the devices. Any device that is FIDO compliant, you know, will be able to work. So it makes it easy for a consumer to go out and just buy a key off, I don't know, some websites that used to sell books, and so on. There's lots available. There are a lot of vendors providing different options. And you know that if they've been FIDO certified, that they're going to work seamlessly regardless of whether you're using it for web scenarios or even native scenarios in a native application. What did I just do there? Oh, CTAP title popped up. Sometimes build slides are a nuisance. So lastly, we have this nice little sketch showing where all the pieces fit together. We have our user and we have our service, which you've seen before. And so now you see where the different pieces fit in. On the left, making sure I get left and right, above the user, you see there's, in this case, an external authenticator. And it uses a gesture. The little circle in the middle is a place that a user would just simply touch to indicate that, you know, the user's there, to indicate user presence. It uses the CTAP protocol to talk to whatever device it is that the user is using. Then you have WebAuthn, which sits between the user or the user's browser and the relying party, example.com, right? The service provider that's going to rely on or depend on this authentication. And it's the in-between point, and you can see that it's the path through which the public and private keys, well, sorry, it's where the private key is used and the public key is shared with the relying party. Again, to emphasize very strongly, the private key never leaves the authenticator, right? That's a really important concept here. So what that leads us to is two basic scenarios that you're going to encounter most of the time with FIDO2. The first is the second factor, which Scott mentioned before. This is a scenario where you still have a username password, but there's now a second step where you're asked to insert a security key, or if it's a platform authenticator, it may just automatically initiate, say, a biometric request, and then the authentication takes place. So in this case, you're still using a password, but you're then using the authenticator as the second factor, the what you have aspect. The other is the passwordless experience. Sorry, I was just thinking of it interesting. We did some user experience studies earlier this year and found out that the term password-free actually sounds less secure to end users, because they assume there is no password, and therefore it's less protected. So we've learned not to use password-free as the term for that. So we have a passwordless experience. And in this case, you have an authentication challenge, which in many cases is often just enter a PIN, touch the screen. Or if it's the facial recognition, it may recognize you and you just confirm, yep, that's good. So steps 1 and 2 are almost seamless, and then the authentication again takes place. And again, especially in this scenario, no password ever goes through the air, over the wire. It's all the public-private key interactions. So again, if the relying party is compromised, then it doesn't matter because all they've got is the public key. So those are the basics. Hope I didn't go too fast on all that. And now after hearing about all the different bits and pieces in the user experience, I'm going to introduce Alex to come up again and scare the bejesus out of you. He's going to talk about what are the threats, what do they really look like, and how Fido helps. Alex?
Thank you, thank you. So my day job is that I run the identity security team for Microsoft, which means that we deal with all the incoming attacks. It is rare day that we don't know what the news is going to say before it says it. We run an investigations team, data science team, incident response team, as well as building things like multi-factor auth, conditional access and such for Microsoft and all the threat detection. Our run rate for incidences runs about 20 a week. That means 20 investigations, 20 major stuff that gets past all the other tiers of support before you get to us. And so we live and breathe the vulnerabilities of credentials. Like, that's kind of what we do. And I'm a fan of Fido. I actually have helped with it over a variety of years, including early Windows Hello. Because, man, I hate passwords. Because everything, and I wrote this paper, Your Password Doesn't Matter, because like everything you do, every piece of advice you get about like, no, here's what you do to make a password secure is nonsense. Because the fundamentals of a password are like crazy. So I love Scott's talk on that. That'd be fun to kind of look at this from a perspective of an attacker. Like, what makes for a really good attack? What makes for a really good attack, one, is I don't have to put myself physically in harm's way. Right? If I can attack from a place that doesn't have extradition, right? If I can go after you and you can't get back to me, that reduces my cost to almost nothing. My risk is very, very low, right? So a remote attack is way better. It's a bummer if I have to sneak up to you and like pick your pocket. A really good attack is undetectable, right? So if you're familiar with the SolarWinds attacks that were detected in December, the thing that was magic about SolarWinds was not that hackers broke in, it's that they stayed undetected in the most secure organizations in the world for 9 months. Right? And if it wasn't for some cleverness at FireEye, like to notice that they were hacked, we would still probably be seeing those folks staying in. Now, part of that is that if you have a credential that can be reused, right, that is durable over time and can be reused by, like a password, right, then it becomes undetectable. Like, I can sit on your account for an indefinite amount of time. So that's another thing that makes for a really good attack. An attack that stays durable. If I can stay resident, I don't have to refresh, I don't have to take an additional action. Every time I have to go do another authentication to get back to access for a thing is another chance for you to detect me, right? So I'd rather not have to do that. Should be cheap, ideally scalable, right? And so cheap means that I can write a script, take a toolbox off the web and run it. And if it scales, I can run it over botnets. I can run it from multiple locations at once. I can attack multiple accounts at once and run on some sort of a statistical probability that something gets through, right? So there's very little targeting. Now, in the real world, right, of what we do with account security, as it turns out, proximity is such a good thing that if I want David, I can get Scott and I'll get to David. Like, I know that, right? I know, like, organizationally, I just need to get somewhere proximate to my target, and then I can start moving laterally, either socially laterally or technically laterally, right? So if anybody running like Active Directory, still running NTLM? Anyway, so, there's lots of ways to move, right? So I just need to get close to you. So the way that attackers really do stuff is they run these massive scale attacks where they'll take this list of, 100 million names and they try, QWERTY IOUP, right? And then they get some number of accounts and then they can start working in from there. So, these are the aspects of an attacker's ideal attack. And when we look at like how cred compromise plays into that, right, being able to do a scaled attack against passwords like password spray, phishing, et cetera, is just perfect. When we look at the ways that like creds can be compromised and we take it up a level, we think, what are we trying to do if we're designing for cred security, right? And so it's useful to look at how attackers kind of think. Okay, what are all the different ways I can get into this thing? When we look at any given option for credential, it's useful to evaluate it against a list like this and sort of say, all right, could I guess your credential, right? Okay, if it's a password, chances are pretty good. It's about 1%. Password spray is about 1%. So the average credential can be guessed. By the way, list of password spray guesses will be about 10 in a normal attack. And 1% of accounts will fall to those 10 passwords, right? So it's super easy to guess. So that doesn't work. Can I guess your private key? Probably not, right? And so if you go down this list, you say, okay, could I if I'm searching for your password, right? Like if somebody else has reused it on another site and then they get breached and that gets into a paste bin, could I search for it? Yeah, right? If I am looking on SharePoint sites for machine IDs to look for the corresponding password, can I search for it? Sure, right? Can it be discovered? Sure. Could a private key be discovered? No. So the things that David was talking about with public key, private key, right? The idea of rooting the authentication in a private key that is never discoverable is pretty massive. So you can kind of go down the list. I won't go through every one of them, but you get the idea, right? That if we can get into a hardware device bound private key sort of situation, we defeat almost every mechanism, right? We can get down here into things like griefing and phishing and coercion, right? And coercion being the big, really the brass ring hard one to get. Anecdotally, we actually know how to detect coercion in certain flows. Like we've got the data science to do user under distress. It's just not clear ethically what you do about it, right? Like this is another one that's been studied in like ATMs, right? Where if somebody's got you under duress at an ATM, do you actually refuse to give the money, right? There's like an ethical dilemma in that. So when we look at the inversion, what makes for a really good secure credential, right? We like a credential that's unguessable. Now that actually turns out to be not super hard. Once we layer an MFA, so OTP, the one-time passcode, is the thing that is delivered to you over whatever channel, right? So if you're using SMS for MFA, the thing that proves that you hold the phone in your hand, least secure of the MFA channels. The thing that proves you hold the phone in the hand is the code that comes to your phone. If you're using your email, the code that comes to the email, you replay that. So the OTP is just a mechanism to prove that the other thing exists, right? But once we layer in MFA, we can go from this like super guessable password to a much less guessable OTP code delivered through a channel, right? We can go from a password that I can give anybody to a phone that I can only give to one person at a time. Right, so we start to layer in like just basic MFA does wonders. It's the reason that statistically we move from this super compromisable password concept into this much, much less, and it's 10,000 times less, likely to be compromised password plus MFA model. But as you go down this model and you kind of say, okay, I want something that's intrinsically multi-factor, so I can't leave my phone behind and get it hacked, or I can't slip one secret out there and get hacked, right? I want something that's can only be used by one person at a time. That turns out to be important for things like discoverability and durability, right? If you authenticating with my factor means that I can't, the chances that I notice I'm hacked go way, way up, right? And so it becomes a much more expensive thing for the person. Locality is huge. If I cannot remotely attack you, that's a big deal. And so if I can get into a world where, if we're using the phone, I got to have it in my hand. That helps me a lot. Although the phone could be a long way from the thing I'm logging into, which just gets us into a few other problems. So then we have uninterceptability. And this one is a tricky one, right? So we have channel jacking. So when somebody does a SIM swap or does a social engineering takeover of your phone, or is able to get into your, like if you have any major carrier, you have a back channel, which is your username and password to sign into your major carrier. You should be using MFA on the back channel, right? Because it's only as secure as the account that secures it, right? And then of course, customer service is always out there to help you get back into your account. And so the best way as a hacker to go take over somebody's phone is actually through customer service or front desk channels, right? And then the last problem we have to try to solve is unphishable. And the reason I highlighted these two in red is because these are hard problems to solve. And in fact, they're super hard problems to solve. Because if I'm sending an OTP over an email channel, right, then the problem here is that I can take over that email channel through any number of mechanisms, right? And there's lots and lots of ways to break the communications channels. Anything that's being transmitted basically in clear text, like SMS is being transmitted in clear text, is highly interceptable. SMS particularly has just a host of vulnerabilities. There's things, who's heard of a femto? Anybody ever heard of a femto? I got one hand. So it's like a little, if you're in a building like this where cell reception is disrupted, you can put a repeater in the building to help cell signal propagate down into the building. Your cell phone will bind to the closest femto, right? Which means that if I'm a hacker and I control that hardware, I get to now intercept all the traffic on that. So if you've ever been to like DEF CON, they will tell you turn off your phone, right? Because everything that's going on your phone is being intercepted because people are running femtos in their backpacks. Right, so SMS is a highly interceptable channel. But the other problem I want to talk about is phishing. So I'm going to go into depth on these two real quick. So channel jacking, just talked about a bunch of this. Mobile phone being the worst. Email is really going to be a function of your provider, but big providers like Gmail and us and others have got pretty evolved threat detection, so that can be pretty good. In fact, as a rule, I would say for a long time, email was ahead of phones. Right, because the phone providers weren't really thinking about the hacking vulnerabilities, and they were for a while super, super easy to break. And again, it's not the phone in your hand, it is actually what you're checking. What you're checking is does somebody control the channel? So if I can convince support to hand the SMS channel over to me, then I have a problem. Now it's detectable, my phone stops working, right? But all of these things, including account theft, become vulnerabilities for the channel, and then I now can intercept the code, so that's a bummer. And the thing to think about here was, did we design this for authentication? Was simple messaging, SMS, was it designed for authentication? And the very clear answer is no. Right? It was designed for ubiquity and for simple messaging, and underlying protocols in the SS7 stack make it so that anybody running a viable mobile operator can intercept traffic from anywhere else. And so you can stand up a mobile operator for about $5 grand, or you can rent from a bad guy's mobile operator for like $50 for an account if you want to like listen to somebody else's phone messages. So it's bad news. So we want something that ideally was designed for authentication, or at least doesn't transmit in the clear. Right, so if we're going to use SMS or we're going to use email, we don't want to transmit the data in the clear. Now, SMS, turns out if you send an encrypted package over SMS, you're sending 15 messages. Like, it's going to get big really fast, right? So the second major problem that's super hard to solve is phishing, right? And when we think about phishing, we think about this like, I send you an email, hey, I'm a prince in some random country, and I'll give you a bunch of money, and just give me, log into this site. Or the simplest trick in the book is I send, David a mail and I say, hey, David, check out this funny cat video. Just sign into my OneDrive to share it, right? And then he signs in, and of course what he's signing into is my malware distribution plus, password collection site, right? So that's the way we think of phishing, is this very simple, you get a mail, you click on it, it asks you for your password. But there's a tool called Malishka that kind of upped the game in a significant way. And what it does is it does a perfect replay of whatever traffic it's seeing from either side, right? And so essentially all you need to do is get somebody to click on the wrong link. And as long as they believe they're interacting with the correct site, so if I was doing Microsoft, I might do a 0 instead of the O, right? And if I can convince you that you're talking to the right site and you ignore the cert warnings, which unfortunately you will because cat videos are super funny and you want to see them so badly that I promise you that like 70% of your users are going to click on that cat video for the promise of a laugh, right? Despite all the warnings. And any of you who do this for a living know the studies are bad on this, right? User behavior is really bad. So this is my normal flow, right? I'm going to say to some app, hey, I'd like to get access. It goes, hey, you need a ticket. Bounces my user agent over to some IDP, identity provider, and says, okay, great. This dude wants to log in, get me a ticket. And then we do some sort of authentication dance, right? And that's that whole challenge, React thing that we were talking about before. I get the challenge UX, right? And then the next thing that happens in an OTP flow is out of band, completely out of band, I get some interaction on my phone. And it's like, okay, here's a code, type that code in, right? So then I go back to the challenge UX, I type in my code, and I'm done. I log in, everything's happy, I get to go look at cat videos, right? So that's cool. The problem with this is this step on this, it's small text, but the step 5, that bottom line that's going around the side, right? That bottom line is you cannot, as a user, you cannot possibly see the difference between that and this, which is where I insert a malicious website into the middle of it. And from a user agent perspective, I see exactly the same stuff, right? I'm interacting with a malicious website. It pretends to be me to the real website so that it can go ahead and see traffic. So I go, hey, I want to log in. It turns around and says to the real website, hey, I want to log in. Real website says, give me your username. It turns around to you and says, okay, give me your username, right? And Malishka made doing this like beautifully simple. So anybody who's willing to go to GitHub and download the code can now do this. And so I wrote a paper where I kind of use this example. So Janus is a two-headed Roman god, right? God of portals. And I think deception, like it's a perfect analogy. So, but if we think about like this two-headed god, like if I'm the dude on the left, so I'm the guy with the beard, and I'm trying to log into a site, in the top flow, the server, the guy on the right, that looks like a perfect interaction. if somebody intercepts and gets them in the middle of that and does a good enough job of portraying the client to one side and the server to the other, then it's undetectable what's happening in the middle, right? And that's all because of that out-of-band authentication, right? So when we look at this, to solve this problem, what we mostly need to do is put the challenge in band, right? We have to do that. And the other thing we have to do is we have to authenticate the asker. We have to be able to say, hey, that person who's asking you for a credential, you know them. You've seen them before. It's cool, don't worry. They're not pretending to be somebody you've interacted with before. They are somebody that you've interacted with before. And then we want to say that furthermore, because users are determined to get to cat videos, right, that we will only release that credential to a requester that we have seen before, that they have to have registered before, or we're not going to do it. So subsequent requests, like we're going to check against that. Do I really know you? And so the thing we didn't talk a ton about earlier in the talk is the registration ritual, right? So authentication is all about rituals. And we have one ritual, which is, hey, I'd like to sign into your site and you've never seen me before, right? And we've all done this for some retail site. It's like, great, what's your username? My username is Alex. Okay, what's your password? My password is QWERTY, IOP, or password123, right? And so we've all done that dance a million times. And that enrollment dance becomes really important because in Fido, we do a little extra handshake to say, all right, but who are you really? And we embed that into the Fido dance, right? So if we go back to this diagram, I moved your private key off of the user and into the token. If we go back into the diagram and we look at all the things I've been talking about, like what makes for a perfect attack, what makes for a secure credential, the thing that is super cool about Fido to me is that it was designed to address the attacks we understand today, right? It was designed to actually, deal with this, and I think it does it in a way that's elegant. So David and I were talking about a demo. We're like, what are we going to do? Like flip open our computer screen and you're signed in, right? There's not a lot to show because the user gesture can be very, very, subtle and smooth. But what's actually happening under the covers is cool, right? I go to register a credential, and so I essentially request enrollment. And I do this dance with example.com. And example.com is going to give me this chance to say, OK, here's my public key. But when I do that, I'm embedding it. I'm kind of basing it on example.com inside with my private key, so I can't release it. So what happens? Well, I verify the relying party when I asked for the creds. So that was cool, right? The user agent here is essentially blind. They don't get to see what's going on. They do have a way to directly interact with the hardware. Right? That's what CTAP is giving us. So WebAuthn talking to the browser saying, OK, go invoke your platform to go talk to hardware. So now I'm able to go in and do this enrollment process in a way that nobody can get in the middle of it. So that's pretty awesome, right? I can ensure that the user is present with a gesture and that the device is present on the session where it's happening. And that's really key, right? So like blind authentication is a problem that we face where you say approve yes or no, and somebody just is like, I don't know what this is, yes, and then the actual session is 200 miles away, right? This prevents that. Like this says the session has to be present at the browser, right? Because the CTAP interaction combined with the WebAuthn means that I'm actually at the user agent when this is happening. So that's pretty key. We have in many authentication flows, we have intrinsic two-factor auth. There are user-present flows that are not, but for the purposes of what I'm talking about, like it's super cool that I can say, oops, I left my Fido token on a table, no big deal. Like it's a bummer that I lost $30 worth of hardware, but it's not a bummer that I'm going to get somebody to hack into my account, right? If you over-the-shoulder me and you get my PIN code, that's not going to help you unless you also steal the token, right? And by the way, all of that requires you get very close to me, and that, as we talked about before, is very, very expensive to do. We have a hardware-bound private key. And the hardware-bound part of this is so, so, so important, right? So another hallmark of December and the SolarWinds attacks was people stealing private keys and using them to forge authentication tokens. And that was done because the private keys were on disk, right? Anything that is in a memory space, an admin memory space on a machine, is accessible. The key here is that there's a baby TPM on these tokens, or there's a TPM in your machine, so that we're able to bind that key into hardware, which means that it can't be released or copied, which is super, super important. Everything, sooner or later somebody figures out a way to break, but right now it's really good. And then this other piece is super important, that we have an encrypted message, right? The thing that's going across the wire is encrypted with that private key, such that somebody with a public key can read it. But if you're a machine in the middle, you're not going to be able to read it. So the Janus attack, that sort of phishing thing is defeated, right? Because it doesn't have anything it can work with. It can't unencode it and re-encode it and try to pretend to be somebody it's not. Can't enroll on your behalf or anything like that. And then importantly, if you look at all the times that you read about this guy breached, that guy breached, 8 billion username password pairs online, right? One of the problems is that we're storing secrets in memory on servers that are useful. But in this world, we store something that is actually useless to an attacker. It's your public key, right? And so this is another nice aspect of this kind of authentication is the thing we store in the server, you could store it in the clear. You could publish it, right? It's okay. All right, we do have some attacks left, right? This is the attack that you're gonna have to deal with no matter what. Doesn't matter how good your authentication is, right? The joke here is, sooner or later, the thing that defeats all authentication is a $5 wrench, right? Is a physical threat. But if you think about the amount of cost involved in doing a single person targeted coercion attack, right? It's extremely high. I have to be very thoughtful about what I'm going after because, getting somebody under physical threat is hard. It does happen, like at the highest tiers of security, we're gonna see people whose families are threatened or whatever, and so you'll get extortion. Extortion's a different problem. All right, if we want to evaluate all the different kinds of credentials we have, right? Everything that you're familiar with, everything you've seen before, and you were to go, okay, going back to that thing about how do credentials get hacked, right? They can be guessed, they can be disclosed, et cetera, right? You go look at all the things that you have, all these even multi-factor auth ones, right? Many of them are susceptible. And the one that really stays susceptible all the way down is that machine in the middle phishing, right? All the way down to you get to things that use this pattern of essentially device-bound crypto, right? So Windows Hello and Fido, and now Windows Hello now uses Fido, so it's essentially the same, right? And some of the old PKI infrastructure around smart cards, which have manageability issues but really good security, are resistant to that interception phishing. Everything else is susceptible to interception phishing. So this is taking us to another level. Now, to be clear, that interception phishing is a thing. It's happening. It's real. Not in the same volume as password guessing, but it's definitely happening. All right, so there's my scary stories about how people get hacked, and why I'm so enthusiastic about Fido is because it does like systematically, piece by piece, address these vulnerabilities. And I think I'm going to turn it back to Scott to wrap us up. Here you go, sir.
Thanks, Alex. So now we have a better understanding of the authentication landscape, a little bit of an idea of how Fido 2 works, and the gaps it is hoping to solve. So let's quickly review those. We talked earlier about that if we were to come up with a new authentication mechanism, it would have to satisfy these 4 requirements. Have to be secure, easy to use, interoperable, and trustworthy. So Fido 2 is secure by design. You have unique credentials per every RP. It's phish resistant. It's using technology that's very difficult to crack, that's asymmetric key pairs by design, and is a standard. Fido 2 is easy to use by design. There's no passwords to remember, there's nothing to forget, there's nothing to lose, nothing to change or rotate. There's no one-time passcodes to wait for. You don't have to give your phone number, your email to these services. There's no auth apps you have to download. And the gestures are simple. It's actually easier to use than what's out there today. You tap, you scan your fingerprint, you scan your face, and we left this open for a lot of innovation, other ways that you can perform these gestures. Fido 2 is also interoperable by design. It works on browsers. You have your popular browsers. It works on the different platforms. And it works in different form factors as well. Finally, Fido 2 is trustworthy by design. It's a standard. We have we have WebAuthn and CTAP. The biometrics never leave the device, and there's no need to share your email or your phone number. And that's it. That is Fido 2 101, and you've graduated. So thank you. We hope this has been helpful. We hope this has provided a good foundation for the rest of the week. And now we'd like to open it up for questions. And introduce Pam.
Hi, folks. All right, let's do that.
Hold on, I have a couple things to say about Q&A first. So you have a few ways to submit questions. If you haven't downloaded the app, I really urge you to do that. The CVent Events app, Find Authenticate 2021, you can actually submit questions right in the app, which is really cool. So I'd urge you to do that. But of course, we have mics set up as well here and here if you want to come up to the mic, or if you want to hang out and have us run a mic to you, that's fine as well. All right, so so do we have any questions in the room? Okay, go ahead.
So, hi, this is David Silver from Asymmetric. So first of all, thank you very much for the presentation. I really enjoyed the three of you. Really helpful. And my question is, there was a clear focus on human-to-machine authentication, right? So I'm really interested in knowing if FIDO 2 also covers machine-to-machine authentication, this particular scenario. And it would be interesting to see what you have perspective would be for machine-to-machine scenario. I'm really interested in that area. And also if there is an easy way to get the presentation as well. So the slide deck. Thank you.
I think the conference will make the slide deck available.
Okay.
And then I don't know if Dave, if you want to take the machine-to-machine.
Yeah, on the machine-to-machine side, check out our session tomorrow or the day after on FDO, FIDO Device On Board. It's exactly intended for primarily the provisioning, onboarding aspects of IoT devices. So it directly deals with the scenario of doing secure onboarding, but using a secure authentication mechanism, again, based on public-private key cryptography. So that's where it's the first step to where we've taken the machine-to-machine stuff, primarily focused at this point on the industrial, sort of large-scale manufacturing. Next phase will be to look at the more consumer-oriented scenarios. But we're absolutely invested in that space.
Thank you.
I have a question from the app, which is so this is with regard to the flow, the FIDO authentication flow, David, that you went through. How will the relying party know the user has been authenticated? What type of information does the relying party receive as the authentication proof?
You want me to take it?
Yeah.
And then all these people who are smarter than I am can correct me. So what's happening is that the private key that's on the device is essentially signing a message that is time-bound, and so that encrypted message is what's transmitted. If the public key is unable to unpack that message, right, then that means that it came from the right person. And so they're sending essentially a cryptographically secured message that is verified by the public key that's stored on the server.
There's also, for much higher level security type scenarios, not the sort of thing that you'd necessarily use in a consumer scenario, but there is this notion of Fido Metadata, which is information about authenticators that gets registered in an available database that the relying parties can use. And it provides extra information about authenticators. It helps you validate that it is an authentic piece of hardware from the manufacturer that said it was, and so on. So again, for the really secure and more specialized and generally not consumer-oriented scenarios, there is this metadata information which provides extra data that the relying party can use to make an authentication decision on.
Thank you, that's excellent. I have some other questions in the app, but before I go to those, is there anyone in the room that?
I thought we had a question of, there's one.
Hold on, and you need to be mic'd because we're live. No worries.
Want me to run this one over?
There's a mic here.
There's a mic right there. Yeah, if we could either pass the mics around or go to the mic for the
In
question.
the meantime, I think we should also, can we scooch forward?
Hi,
Do
I'm
whatever
Bruce.
you want, yeah.
You guys over there.
Hi, I'm Bruce Javan, Easy Dynamics. So you mentioned in the higher security scenarios, there's a metadata, but without those higher scenarios, is there general context around the authenticator that's also delivered, such as, hey, we use a biometric versus a gesture or something to get in some of the authentication context?
I could probably take that if you want. I do believe that's actually some of the data that's being updated in the next rev of the spec, is to give more data about what exact mechanism was used. The thing that you have the ability to negotiate right now is the strength, whether it's user presence test or user verification test. So you have that sort of ability to know what level you're at. But I don't think right now in the current version of the spec you can actually say, was it bio, was it PIN? We do have some experts in the audience. Does anyone? John? No one? All right. I'm assuming that I'm saying the right thing because nobody has. Yeah. Usually the denouncements flow fast. Otherwise.
So out-of-band verification,
Yeah. Yeah. But there is more coming.
the denouncement standard.
The denouncement standard. Denouncement as a service. That's pretty
I think
good.
I thought we had a question over on this side, but maybe I was just.
I think it was Christine acting as a proxy. Here we go.
Hi, Michael Ramsbacker, MyTech Systems. So in the event, I do the enrollment dance and I have my Authenticator on my phone. I'm fat and happy, I'm secure, everything's working great, and I lose my phone. How do I regain access without falling back to some of the factors that were vulnerable that were discussed? Is
Right.
that in the standard?
This is the like $64,000 question. Go
Sorry.
for it.
I mean, so the practical answer is, so among other things, my team is responsible for account recovery at Microsoft, and so, and it is a hard problem. Ultimately, what we want to try to do is encourage people to have multiple trusted devices. So you bootstrap multiples, right? If you get out to where there are no remaining trusted devices, then you're going to go through some sort of recovery ritual. If it's in a corporate setting where you have some sort of security desk and you can walk to some building and do the dance, that's easier. In a consumer environment, that's much, much harder, especially if you're not doing hard verification of things up front and you fall back to heuristics. But the short answer is the whole point of having really, really secure authentication, right, is that if you can't do that thing, you probably want to have something really, really, really secure to replace that thing. And so the burden of, while the likelihood of like passwords get forgotten, about 70% of users forget a password in a year, and about 60% of those will forget it more than once in a year. And comparatively, we hope that with FIDO, the variety of devices that are available, the ability to include it into your laptop and that sort of thing, that problem goes much, much lower. But the recovery, I think the bar goes higher, right? Because you're no longer saying, hey, what's your mother's maiden name or your favorite dog or whatever. The only reason that was ever acceptable is because passwords are so awful that you might as well give them away, right? But once you get to FIDO, you're now in a world where you'd say, okay, no, this is a real credential, so we want a real recovery process. And so I'd say, number one, try to avoid needing it, because it should be hard. And then, so have multiple devices. And number two is design your recovery flows well, because now you're talking about a real authentication.
Right.
If I could just add to that. Again, work that's underway in FIDO now, and there is a session on it, identity verification session, at least one, again later this week. One of the common mechanisms being used for account recovery is a so-called selfie matching. And this is one where you take a picture of some kind of trusted picture ID, like a driver's license, and that gets sent in, and then you take a picture of your own face, and they do matching your face to the picture on the card. It's a great solution for, given that it's better than most or better than many, although it's still not great. But the real problem, though, is that how it gets done, the level of quality, how much trust is in this, is all over the map. So what FIDO's doing, we already have a very solid secure certification program in place. We already do hardware biometric certification. We're now doing identity verification certification, so that for that scenario, we're actually setting testing standards for what's the bar you have to pass for validating that it's an authentic document. What are the standards you have to set for, or what are the testing requirements that you need to pass to ensure that you're consistently doing proper recognition of the face to the photograph, much like you have with biometrics now. You have false acceptance, false rejection rates, and so on. So we're almost ready to publish, in fact, or at least provide to the first testing services the certification for the document authentication part of it. So we're well on the way to developing those, and it's intended to provide a standardized level of evaluation for those systems for things like account recovery.
Right. And I mean, there's a lot of answers to this question. But I think the other thing that it could be a useful tool is the NIST 800-63 specifications. They actually have they lay out some best practices as well that are really worth meeting, right? So, for example, one of the big rules is you never recover a strong authenticator with a weak authenticator. So you have to be able to, get up to the right level of being able to recover your strong authenticator. And so you can do that by stacking authenticators. So you can email and possession of email, possession of SMS, and some kind of interpretive dance might get you to the point where you can recover, right? So some of these things are way beyond FIDO. They're about what your overall security practice is, and then there are a couple of things about cryptographic recovery that people have proposed in the FIDO Alliance additionally.
But at the risk of going way too deep on this one, it's an area of particular passion of mine. It's not you don't recover a strong credential with a weak credential. It's you don't recover a strong account with a weak credential. Because if you allow recovery of the weaker credentials that stack, you've blown the top one by compromising the low one. So attackers will start at the bottom, and they'll change the password, then the phone, then the email, then they'll use those three to change the authenticator. So it's the account that matters, not any particular authenticator on the account.
Hi, I was wondering what research has been done for like the need for out-of-band gesture delivery to protect the private key or whatever, the FIDO2. So like if you had either like the non-mobile authenticator, and as a reliant party, you can't really even mandate like what gestures used for delivery, like what's to prevent a compromised device from just repeatedly making use of the FIDO2 authenticator.
Want me to try? Okay. I think what you're asking is what keeps us from having, I want to make sure I parse it right. What keeps us from having, if you have a compromised FIDO device that is essentially bypassing the need for the gesture, like it's a hardware compromise of the FIDO device. I think some of the certification standards and that sort of thing are a really important part of it. And we want, I'm loath to say you can't crack open the hardware. Like if somebody breaks open a FIDO token and somehow shorts it.
I don't mean so much the FIDO token itself, but like that's just a secure computing device, right? That signs the challenges, right? But if it's part of a computing like a laptop, right? What's to prevent malware on the laptop from just?
Would you mind going to the mic, sir?
Sorry.
Thank you.
So I'm going to repeat that question. Question is, what's preventing malware on the laptop from triggering the authentication?
Yeah, exactly.
Yeah, okay, so that's super helpful. So the gesture is done at the authenticator, not by the laptop, if that makes sense, right? So the laptop can't, the laptop can't say, like, I'm now telling you you've touched the FIDO token. Right, or like entering the PIN.
Yeah,
still has to be transmitted to the FIDO.
Because I know with the smart cards, they used to sell the special keyboards where like the number pad would go directly to the, or like with retail devices, the cards, the credit card or whatever is inserted in its own reader and the PIN.
So you're saying like if I intercept your PIN through system level malware,
yeah, exactly.
And then I just call the APIs and keep sending it down at the right time.
Yep.
So that a relatively heavy device compromise on the laptop.
Right, and I think there are vendors here who can answer that question maybe better than we can, right? Like I think if you go to the Ubico booth and ask them, part of it is, as I understand, is it doesn't go through the keyboard queue. But like I said, right. I'm hitting the level of my.
Yeah, I know in Windows we have a bunch of protected code pathways there. Right. I think it's above my knowledge base to say exactly what the mechanisms are.
So we can follow up with anyone who wants to know the answer to that question. Come find us afterwards, and we'll find out the answer and let you know. Because it's a good question.
I think we have time for one more question.
Ta-da!
Hey, Chad Spensky from Authenticate. So my question is kind of about the scope of FIDO. So one of the bigger attacks is like the session hijacking, right? So once you're authenticated, you can just hijack the session outright in a lot of instances. Are you guys thinking, like, is FIDO going to now do like guarded actions? I don't know how you guys phrase it internally, but like, okay, I logged into my bank and now I go to transfer money. I should actually like somehow convince you that I am me for that transfer, right? Like right now, my laptop's right there. You could run over and wire yourself money. Like, are you guys thinking about that, and where do you see this going?
You want me to take that?
We can't see each other.
So,
We're all like,
yeah.
Well, David, why don't
Podiums
you
are like,
start?
the short answer is it's not necessary. FIDO provides the authentication mechanism. What you're describing is a flow of sorts using authentication multiple times. So what you would have in the situation of a bank and bank transfers is you may log into the site and you use FIDO for authentication. You're now on the site. Everything's fine. You can do things. Now you want to transfer. They're going to go, hold off. Let's just make sure nobody else has stepped in the meantime, so I'm going to authenticate you again. And so you're going to go through another FIDO ceremony, which may be a fingerprint or maybe a PIN again.
Okay.
So it's using, because it's just 2 discrete authentication steps that you're actually using in that case. In some cases, it's used as a step-up authentication too. You log in, say, with your password, and then you want to do something important. They say, hold up, now you've got to use the stronger thing. So there's different combinations depending on the scenario. But in the scenario you described, it's just doing authentication twice.
Okay. And I remember early in the protocol, I haven't followed all the modern, like the current stuff, but the verifier was able to effectively say, like, I want this level of authentication. Like, they could say fingerprint specifically. Is that still part of the thought process?
Anyone? Any old timers? David, I guess you're.
Yeah,
Oh,
I think UAF. Yeah,
Yeah,
UAF had that capability. Oh, Bill, here we go.
There we go.
Yeah, I definitely qualify as an old timer on many categories. So that's part of where the metadata service, where you can figure out what kind of authenticator is. But in general, the policy's been to discourage relying parties to say, oh, I want this or I want that,
Okay.
so that we can encourage a broad set of authenticators to be used. Because we don't want to diss any particular one unless they're really bad and there's some security flaw and they're known about. But in general, let the consumer, the whole initial premise of FIDO was that the relying party would say, hey, authenticate, and then the consumer would say, oh, I've got this. It's like, okay, great, use that. So very inclusive was the intention. Okay. So not to diss any particular authenticator. There is a distinction between, as was discussed before, user presence and user verification. User presence says there's somebody at the keyboard and there's a live person there. What you'd use the PIN in the system, as Alex talked about, before you put in a PIN, and then you have a live presence and a separate TPM on that key, right? And then user verification is, yep, that's actually Bill's fingerprint on Bill's device. We've seen it before. We know it's Bill, not just somebody else who has a PIN and can touch that device. So
Gotcha.
That's kind of the big distinction you'll see is user verification, user presence, but actual picking out a single device, no.
Yeah. And then,
device type.
just to super quickly, I think you're actually in some sense asking just a general authentication question. It's not, because at any given point, the relying party might say, I'd like a fresh verification, please. From any, even if it was a password, you can go back and say.
Yeah, and I guess I was more asking from like the developer point of view, right? Like, is this going to be encouraged, or are you going to like try to put out APIs for this to say like, hey, we make it really easy to just like recall this thing, like,
Yes.
hey, prove again that this is a security critical thing. Let's double check, make sure it's still chat.
We're literally, I think we just announced a feature on that in AED. Like it's definitely a thing that we're doing is to encourage people to say, there's a whole bunch we can't understand about what's going on inside your app, right? And you need to say, hey, this is a moment, And so yeah, absolutely, we're working with developers to do that.
Awesome.
And not just us, like just everybody.
Yeah, if I could address this also. So there's, in the original FIDO UAF, which now become, the original FIDO requirements in which now become UAF, there was a requirement for essentially transaction confirmation, which PSD2 calls dynamic linking. So that was in there. And long history of politics and different companies coming in, we now have FIDO2 and UAF, and FIDO2 has kind of taken over a lot of things. So FIDO2, because of the complexity of coming through a browser and all the way down to the operating system, TPM, and everything else, is a really difficult problem. And the original, what's now UAF spec, basically was use a secure display, okay? But a lot of vendors, including the company I work for, Login ID, have built a transaction confirmation mechanism that says, do you really want to send Bill $1,000, swipe your finger, and that gives non-repudiation. But we don't get a secure display out of that, okay? But so if you were actually able to take over my machine sufficiently to trick me, you know, it's not what you see is what you sign kind of thing.
Yep.
But there's most of the vendors you see will have a transaction confirmation mechanism at the moment of the transaction, because PSD2 requires this dynamic linking for anything over 30 euros. A lot of details underneath that, but yeah, it's you have a talk on Wednesday afternoon about authenticated payments decoded that I'll go into a little bit of this.
Okay, awesome. Thank
Thank
you
you
so
so
much for
much.
the thorough answer.
We do have to wrap. Can you all please, that was fantastic. Can you all just join us in thanking Alex and Pamela and Scott and David for a wonderful FIDO 101 session?